Okay, so today is going to be a review. What we're going to be doing today is to solve and graph inequalities in one variable. Okay. What I want you to do right now is I want you to kind of think of some words other than just less than. So these are the four key terms that we're going to talk about in this section. Less than, greater than, less than or equal to, greater than or equal to. I want you guys to think about terms that you would use on a daily basis. So instead of saying less than, maybe I would say under or below a number. What's something else maybe you might use? Smaller than. That would work. What if we were talking about a height? What would we maybe say? Shorter. So sometimes it's more specific to what we're exactly talking about. Little. Littler, I guess would be, but littler, I think we would just use the word smaller. Probably right. So, what else? How about fewer? Fewer than? There's a couple of them. All right, let's talk about greater than. What other words could we use instead of greater than? More than, that one would work. More than. Go ahead.
Bigger.
Bigger or larger. Those would both work. What else? Go ahead.
Above.
Above. So it has to be above a specific number. What is it? Taller, yep. That would work. Taller. Or over. Has to be over something specific. How about exceeds? That might be a word that we would use. To exceed a specific number. How about the less than or equal to? At most. Good. At most would mean it has to be less than or equal to a specific number. Anything else? How about a maximum? It would have a maximum if it has to be below or equal to a specific number, right? It would have a maximum then. Anything else? No more than. Very good. I feel like those are the harder ones to think about. No more than. That's a good one too. How about greater than or equal to? At least. That's good. Minimum. No less than. That one's a little bit easier now that we've already thought about the opposite, right? No less than. All right, so this next part is just so that you can see the properties that go along with an absolute value. So can we all agree that -4 is less than 10? Okay, so if we took a number and added it to both sides, like let's say we were to add 3 to both sides, what we would end up getting, just like in an equation, is that -1 is less than 13, which is still true. Okay? So that means that we're allowed to add a number to both sides, and the inequality will remain true. Okay, so adding a number to both sides, good, that is okay, we can do that. All right. If we're subtracting a number from both sides, let's try that. So subtract a number, it doesn't really matter what number we're subtracting. This is now going to be -6 is less than 8. And is that still true? Yep. So when we subtract, that still works also, because it remains true. Okay, those numbers are still going to be the same distance apart on that number line. We just shifted them this many units to the left or this many units to the right when we're adding or subtracting numbers. All right, can you kind of visualize that? And if it's to the left on the number line, then it's less than the number that's on the right. Okay. All right, so we've added, that worked out fine. We've subtracted, that worked out fine. Now, what happens if we are to multiply by a number? So let's multiply both of these sides by 2. What do we get if we multiply both sides by 2? -12 is less than 16. Did that work? Is that still true? Yeah. So we can multiply by a positive number. That worked. Okay. Watch what happens, though, when I multiply by a negative number. This ends up being positive 24 is less than negative 32. Is that true? No. So how can I make it true? What do I have to do in order to make that statement true? I need to do what? But when I multiply, those are the numbers I get. So I have to change the sign to make that statement true, because 24 is not less than negative 32. So what happens to the sign? It switches to the greater than symbol. Okay? So that means when you multiply by a negative number, you must flip the sign. Okay? Now the reason is because on the number line, as soon as you switch it to as soon as you multiply by a negative number, what happens is our sign changes. So wherever those numbers are at, they're going to flip-flop. Okay, so the one on the left is going to become the one on the right, and the one on the right becomes the one on the left, which is why you're going to have to change that greater than or less than sign to the opposite one. Does that kind of make sense? Does that ring a bell from back in Algebra 1 when you did inequalities? And the same works for division. So we could have divided by 2 and it would have worked out fine, but if you would have divided by -2, you would again have to flip the sign. Okay, so multiplying or dividing by a negative number, you'd have to flip the sign. All right, so we have some example problems here for us to work on. And all you have to do is get the variable by itself. So it's very similar to solving an equation, but the one difference is you just have to be careful when you deal with multiplying or dividing by a negative number. So to get y by itself, what am I going to do here? Add 6. And I get that 9 is greater than y. Now, when I do this, I really like it so that my y is on the left side. So I rewrite this, so y, notice that the arrow side is pointing towards y, so I have to write it like this way. Y is less than 9, and that would be my answer. Okay. When it goes to graphing it, okay, this was why we discussed how to plot numbers on a number line the other day, because we need to make sure that we know how to plot where 9 is and where is y less than 9. When you're writing a number line, if this is in between two numbers, please show me what two numbers it falls between. Does that make sense? And show me which side of the number line are we on. Are we on the left side of 0 or on the right side of 0? So in this case, I'd probably do 0 and maybe put like 2, 4, 6, 8, 10. 9 is right in between 8 and 10. You could have gone up by 1s if you want, but that would have been a lot more dashes that I would have had to draw in there, so I didn't really feel like doing that. So 9 is going to be right here. I'll write it in on just that one. Now you may remember, but when you are graphing, you have to have an open circle or a closed circle. So if you have a less than or greater than sign, you're going to use an open circle. But if you have less than or equal to or greater than or equal to, you use a closed circle. Does that ring a bell? So if it can be or equal to, you fill it in like you shaded that part of the graph. So that's for your graphing purposes. So in this case, we're going to use an open circle on 9 because it doesn't necessarily, 9 is not less than 9. It would be equal to. So 9 doesn't work. And then what numbers are less than 9? Is it going to be to the left or to the right? To the left. Left is less. So I shade this part of the graph and make sure to shade where that arrow is also so you know that it continues in that direction. Give me a 1 through 5. I totally remember doing this. I could have done that on my own, down to a 1. I've never seen these symbols in my life, nor have I ever graphed on a number line before. Okay, cool. All right, let's try the next one. Now the next one we might need a calculator for because I don't do decimals well. The only time we have decimals as an answer is if the question gives us decimals. Okay. Other than that, we always leave our answers as the most reduced fraction form. So in this case, I can see that they gave me decimals. So I would get x alone, and I would divide by 4.2 on both sides. I'm left with x on the left. Now, I divided by 4.2. Do I need to flip that sign? No. I divided by a positive number. My sign stays the same. Some people get mixed up because this was a negative. It doesn't matter what the number was. It matters is that orange part. Did we divide or multiply by a negative, and we didn't? So the sign's going to stay the same. And then what's negative 31.5 divided by 4.2? Maybe we'll do that in the calculator. Negative 7.5. And again, it's acceptable to use a decimal because they gave us a decimal to start with. Okay. All right, so then we also have to graph this. So let's draw our number line. All right, are we working to the left of the number line or the right of the number line? The left. So I'm going to put 0 over here. Here's 1, negative 1, negative 2, negative 3, negative 4. I'm getting a little squished over there, sorry. I'm not going to be super picky on how accurate this is as long as I can generally see that you know where these numbers are located. I'm fine with that. What two numbers does negative 7.5 fall between? Negative 8 and negative 7. And is that going to be, so there's negative 7.5. I'm going to label it. And then when I go to graph it, is that going to be a solid circle or an open circle? This one's solid because it's or equal to. So I'm going to draw my solid circle. And then this is greater than or equal to. So the numbers that are bigger than that fall to the right. So I'm going to shade to the right. Now remember how I said I like my variables to be on the left side? And I do that because the sign actually shows you which way to shade. See how it's pointing to the right? Then I know I'm shading to the right. So that's why I do that, where I put my variable on the left side. Okay. Flip it over. Number 3 up here. Now this one has variables on both sides. Don't get scared. It's going to be the same way that we were doing it with equations. You just have to get the variables all to one side. So it doesn't matter if you move them to the left or to the right at first. I would solve it the way you would normally solve an equation. And then if you need to flip it around, you can at the end. I like to deal with positive x values. So what I would choose to do here is subtract 3x from both sides first. Okay, but then my x's would be on the right, so I'd have to flip it in the end. Okay, so maybe you're going to choose to subtract 6x from both sides to move it to the left, because that's where you know you want your x's to be. So if I subtract 6x on both sides, I would get negative 3x minus 10 is less than or equal to 14. And then add 10 to both sides. And you have negative 3x is less than or equal to 24. What happens in this next step? The sign is going to flip because you're going to have to divide by negative 3. And because you divided by a negative number, our sign has to flip. And on this side, 24 divided by negative 3 is going to be negative 8. So you have to remember to flip the sign when you divide by a negative number. You can't see that. Just put a little side note there. Now, if you would have done it the other way, where at the very beginning you were to subtract 3x, you wouldn't have ever divided by a negative number, but in the end, when you would write it the opposite way, because you would have ended up here with negative 8 is less than or equal to x, when you were to rearrange it, you would end up flipping that sign anyways, and you would get this. So it doesn't matter in the beginning which side you move the x's to. You will get x's greater than or equal to negative 8 either way you go about it. Is that okay? Okay, cool. We do have to graph this one. So are we to the left or to the right of 0? If we have to plot negative 8, is that going to be to the left of 0 or to the right of 0? The left of 0. We're on the negative side, so I'm going to put my 0 right over here. I'm going to just count by negative 2's. Oh, sorry. There you go. So I counted by 2's. That way I got there a little bit quicker. Negative 8's right there. Are we going to have an open circle or a closed circle on negative 8? Closed. So I've had my closed circle. And do I shade to the right or to the left? Which numbers are greater than or equal to negative 8? The right. The right are those larger numbers. And you could always test it because anything that is shaded is a solution. So check which one. Is 0 greater than or equal to negative 8? Yep. Cool. I shaded the correct way. So you can always plug in a value. I usually plug in 0 because it's super easy to. Is 0 supposed to be a solution? Yep. Is it? Yep. Looks like I'm good. All right, so this next example, this one has a fraction in it. Do we like fractions? Yeah, some people do. Most people probably know. How can I get rid of the fraction? Multiply both sides by 6. So multiply by that denominator and you'll get rid of it. So if I multiply this side by 6 and multiply this side by 6, I'm going to get 12c is less than, my 6's go away here, and I have 12c plus 58. Which side do you want to move the variables to, the left or the right? It doesn't matter. Either way, what are we going to have to subtract on both sides? 12c. And when we subtract 12c on both sides, something weird is happening. And they both go away. And my answer on the left, what's 12c minus 12c equal? Zeros on the left is less than, what do I get on the right? 58. Okay? Now, there's no variable here. So this one is a unique situation, and we have to ask, is this a true statement or is it false? It's true. So because it's true, it doesn't matter what we would have plugged in, it will work. So we can plug in any number and we're going to get a statement that looks like this one where 0 is less than 58. If that means we can plug in any number on the number line, what is our actual solution here? It's not 0. I'll draw it first. So here's our number line. Oh, I'm really bad at this today. Here we go. Here's our number line. Here's 0. Here's 2. Here's 4. Negative 2. Negative 4. If I take 0 here and I plug it in, I'll have 0 is less than whatever 58 over 6 is, and that's a positive number, so it would be true. If I plugged in 4, it's going to get me a true statement. If I plug in 2, it's going to get me a true statement. Because this right here tells me it doesn't matter what I plug in, I'm going to get a statement that looks something like this, which would be true. So that means where 0 is shaded, and 4 is, it's be shaded, and where 2 is, it's shaded. And everything between these numbers are shaded. So if everything on the number line works, how would I write my solution to this? How would I write my solution? And this goes back to 1.1. What do we call the numbers that we've been talking about this year? Or that you guys have been talking about your entire life? Real numbers. Yeah. So our solution here are all real numbers. Anything on this number line is a solution. And the number line is what represents all real numbers. So in 1.1, when we were talking about the number sets, it could be a rational number, it could be an irrational number, it could be an integer, it could be a natural number. All of those are real numbers, which make up that number line. Okay, so if everything on the number line works, then we write all real numbers. If we simplify it though, and we got something like zeros greater than 58, that means anything we plug in, we're going to get a false statement, and it won't be a solution. So if this would have been false, if that was a false statement, then we wouldn't shade anything, and what would we say the solution would be? No solution. So that's what this space down here is to do, is if there's no variable, we have two options, okay? If there is no variable and the statement is true, for example, like up there above when we had 0 is less than 58, that's what it would look like. Then we'll write that our answer is all real numbers. And our graph will look like this. A number line with 0 on it, and everything will be shaded. What's up? What's your question? Yep. Yep. So in this case, we would write, if we wanted to use the sign, the real number set. Now, some people confuse this, and they want to put like an I and then an R. It's not an I. It's literally an R with just an extra line there. So, yes, you can write all real numbers. If it was false, this would be An example, let's say it said 0 is greater than 58. We know 0 is not larger than 58. That means anything we plug in is going to give us a false statement. And if it's false, it tells you that's not a solution. So if you can't plug in anything, then it's going to be no solution. Okay. If it's a false statement, then it's no solution. And when we go to draw our graph, put a 0 on it so I know you've at least looked at the graph, because a lot of times the line will be there for you to do the number line. If you put a 0 on it, it tells me that you started the problem, but you knew there was nothing to shade. Does that make sense? So at least then I know you looked at it and said, yep, this is what it's supposed to be. No shading. You don't have to worry about shading anything because there's nothing to shade when there's no solution. And that's it. Do we have any other questions? No? Cool.